Hi everyone. So in our last video we talked about an organic compound and organic compound classification, how was the history, and also we saw key points in organic compound structures. So in today's lesson we're going to be seeing the nomenclature of an alkanes, alkenes and alkynes, and also aromatics. So first of all, let's see the aromatic naming or their common naming. So mostly in exams, the teacher's favorites are those. So you better memorize that. And for the common names, we are actually going to be memorizing this. We do not have any trick, but just to memorize it. And I'm going to show you the steps through for the IUPAC naming of the aromatics and alkanes, alkene and alkyne, and we're going to be solving some questions. So in the aromatic ones, the common name for methylbenzene. So this is benzene structure. So if you have one substituent, which is a methyl, is going to be the common name for it is a toluene or methylbenzene. And if it have a substitution of an OH, which is an alcohol, it is called a phenol, which is a hydroxybenzene. And when the substitution is an amide, which is an amine, it's going to be aminobenzene or aniline. And if it was in this structure, which is a common structure for C6H6, it's going to be benzene, C6H6. And another one is another case, which is anisole, which is with OCH3, which is an ether. And when this structure is called acetylene. And another one is benzaldehyde, which is when the substitution function is an aldehyde. We're going to be seeing the IUPAC naming or nomenclature of an aldehyde in our next video. And benzoic acid, I also prepared another video based on all the 8 structures, which are that of a ketone group, an alcohol group, an ether, an ester, an amine, an amide, and also an amine and a ketone groups. So this structure is when the benzene have a substitute function of a carboxylic acid. So this is called a benzoic acid. This is actually the common name. The IUPAC name for this structure is that cyclohexane carboxylic acid. And for the common name of an alkane is the N, the iso, and the neo. So N is used when the carbon atom is continuous chain. For example, look at this structure. So this structure is also called a complete structure form, which is by used a single or a double dashes between them, which is going to be, so this structure is also called N-butane when there is the function or when the carbon chain atom is a continuous chain, there is no substituent function. So you're going to be using N for naming this alkene. And another one is which is an iso. So iso is when the structure have another substituent function in the second carbon. So this form is just like a tetrahedral, which is not a tetrahedral, which is a trigonal planar structure. So it's going to be an isobutane. So isobutane is called because it have 4 carbon containing. So methane for 1, ethane for 2, propane for 3, butane for 4, 5 for pentane, hexane, heptane, octane, nonane, and decane. And it goes on like that. So iso is used when all of the carbon chain is continuous except one next to the last carbon. And another one is neo. Neo is used when the central carbon is bonded to the 4 other carbon atoms, which is just like a tetrahedral shape. So in this case, it is bonded with 4 carbons, as you see here. Just like a tetrahedral shape, it's going to be forming 120 degrees, and it is connected to 4 carbons, so it is called a neo. So which means that there's 1, 2, 3, 4, 5, 6, 7 carbons totally. We're not going to be using the carbon in the chain only, but also in the substituent, because it's this common name for alkenes. So we're going to be saying neoheptane. And what you need to be careful is that when naming in those things, count all the carbons both in the substituent and the main chain, which makes a confusion in many students in a test, because they are going to be using, just like the IUPAC naming, they're going to be counting 1, 2, 3, 4, 5. Oh, it's 5 carbon, so we're going to be saying pentane. So actually we got the right answer is going to be a neopentane, but actually that's incorrect, because the answer is going to be, we need to use all the carbons. We're going to be counting all of them, and then we're going to be saying neoheptane, and this is also going to be isobutane. There's a 4 carbons, and here it's just we're going to be using the linear chain, which is going to be N-butane. That's all for the common naming of an alkanes. And it also goes on for the alkanes and alkynes. It's the same, which is going to be using, if it's for the alkanes, they're only going to be a double bond here. So if the double bond here, there's no going to be change other than the parent. So it's going to be isobutene. So ANE is going to be replaced by ENE suffix. So if it was an alkyne, so it's going to be a triple bond here, or it might be here. So it's going to be using isobutane. So it's going to be ANE is replaced by YLE. So alkyne. YLE. So that's all for the common name for those linear chain hydrocarbons, which are alkanes, alkene, alkyne. And for the nomenclature of common aromatics, remember, those are teachers' favorite hydrocarbons. So toluene, when there's a substituent or a methyl group in the benzene structure, and when there's OH group or a hydroxyl in benzene, in a phenyl, it's going to be phenyl. And if there's an NH2, it's going to be amylene. And this structure is basically a benzene. And there's also another one, which is teacher's favorite, which is this structure. So it goes on like this, and this. This shows that there's a delocalized of an electron in this structure, in benzene structure. So it's not a double bond, it's not a single bond or a triple bond, but it is at most, So there's a delocalized of electrons. So this structure for the common name is that naphthalene. And for the fused one, if it's going to be fused, just out of this, and then it goes on like this. This is called a fused aromatic hydrocarbon, which is called naphthalene also. So this is a fused aromatic hydrocarbon. So naphthalene is that when this structure is added, and when it is fused with another benzene structure, it's also called naphthalene, which is generally it is fused aromatic hydrocarbon. So now let's move on to the IUPAC naming. So we're going to be starting to use those exercises. So as we say in the nomenclature for the common name, there's N, which is for the linear one. So the common name is going to be N. There is 1, let's count. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 carbon, which is going to be octane. Let's move on to this one. So this one have there's going to be counting from the nearest substituent group. So if we count from this 1, 2, 3, 4, this constituent group is going to be at 4 carbon. But if we moved from left to the right, we found that 1, 2, 3, 4, 5, 6, 7. So at 3 carbons, there's a substituent methyl group. So we're going to be using this one. So let's write 3 methyl, 4 ethyl. What is this called? A heptane. So ethyl heptane. But this structure is incorrect, because in IUPAC naming we're going to be following an alphabetic order. So this means E comes before an M. So we're going to be exchanging places. So the correct structure or the correct IUPAC naming for this compound is going to be 4 ethyl, 3 methyl heptane. This is correct. And let's move on to this one. So if we see that at 1, 2, 3, 4, and this is another one, there's 1, 2, 3, 4. So it's the same. If we move from left to right or right to left, we're going to be finding an ethyl group. And this one is a propyl group, which is 1, 2, 3. So it's a methyl ethyl propyl group. So if we move from this one, 1, 2, 3, 4, 5. So we're going to be using an alphabetic order. So let's see, an ethyl or a propyl comes first. E comes before P. So the alphabetic order is going to be from the ethyl to propyl. So you're going to be using this one, which is going to be 1, 2, 3, 4, 5, 6, 7, 8. So the answer is going to be 4 ethyl, 5 propyl octane. If this have a double bond in this one or in this direction, it's going to be octene or octane. For example, let's see if we add, where can it be? Here. If we add a double bond here, so this function is not an alkane, it's alkene. So our answer is going to be 1, 2. So it's a double bond at 2. So we're going to be using the nearest direction for the functional group. Even if there's a methyl group here, we're going to be counting the number from this direction because we're going to be favoring the functional group. So we're going to be 1, 2, 3, 4. We're going to be 4 ethyl, 5 propyl. There is double bond here, it's going to be 2, and then it's going to be octene. And let's move on to this one. So this one, 1, 2, at 2 there is a 2 methyl group. 3, 4, in the 4 there is an ethyl group, and at 1 there is a propyl group, methane, ethane, propane. So at 1 there is propyl, and then 1, 2, 3. At 3 there is ethyl, and 1, 2, 3, 4, 5, 6. At 6 there is also another, which is going to be dimethyl, and then the overall is 1, 2, 3, 4, 5, 6, 7. No, 1, 2, 3, 4, 5, 6, 7. Yeah, it's going to be heptane. But this is the incorrect structure because we're going to be following alphabetic order. So let's move on to this one. Let's order it. So it's going to be E comes before P, E comes before T. So it's going to be 3 ethyl, And then we're not going to be seeing the D actually. We're not going to be including the prefix in here in this case. We're going to be only seeing the M. So before M and P, which one comes first? So basically M comes before P. So it's going to be 6,6-dimethyl and then 1-propyl heptane. But this is not correct, as you see. We make it a mistake, which is there 1, 2, 3, 4, 5, 6, 7. It's heptane, it's correct. But the propyl is at the Q carbon, it's not 1. Another thing is that the ethyl is at the false carbon, which is going to be this one to be 4. Now we are correct. Another one is this structure. So look at it and try to do it on your own first. So as we see here, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So and there are also 2 substituent groups. And the overall carbon is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And which is going to be making, there's 1 propyl group here and 1 ethyl group here and chlorine group and a bromine group. So we're going to be going to this direction. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. It's not going to be including this one because it's a bromo, not carbon. There's only carbon in here. So let's just write it casually here first, and then we're going to be ordering it. So first there's a propyl, and in the fifth one there's an ethyl, and at 6 carbons there's a chloro, and at 9 there's a bromo, and then what? It's so it's going to be 9 bromo. No, it's not going to be a 9 bromo. We make it a mistake here. It is actually, there is also a carbon which is attached to the bromine. So I wanted to find out which one of you are going to say you are incorrect in the comment section. Actually, I make it a mistake purposely. So let's move on. If you already commented, then thanks. I mean, you got this. It shows that you understood the section properly. And moving on to this one, so it's going to be 10 bromo, which is there's a 10th carbon here. So the main chain which contains 10 carbon is called decane. So it's going to be bromo decane. So now let's exchange this based on the alphabet structure, alphabet order. So it's going to be E comes B, C. C comes before all of them. No, B comes. So it's going to be 10 bromo. And then 6 chloro. And then 5 ethyl, and lastly 1 propyl, and then decane. But here's it's also incorrect because we can follow the increasing order of numbers. Look at this one. We can also find another name for this compound, which is actually like this. Look carefully. So in this case, there is at the carbon 1 there is a bromo and also a propyl group. So if we go from left to the right, we find this. But what if we go from this to this one? Let's check it first. So it's going to be 1 bromo, 1, 2, 3, 4, 5 chloro, 6 ethyl, 6, 7, 8, 9, 10. 10 propyl. And then a decane. So look at this one. From 10 and 1. Which one is the smallest number? It's going to be 1. Because it's going to be at increasing number order. So our answer, which is when we come through this kind of equation, we're going to be using the lowest number as possible. So our correct naming system is going to be 1 bromo, 5 chloro, 6 ethyl, 10 propyl decane. This is the correct structure. Now you know. And let's move on to another examples. So let me find them. So moving on to this question. Now look at the structure, this kind of complex structure. So now let's move on. As we see these, there is a double bond here, and there's 2 methyl constitution, sap constitution in here at 1 carbon. So do we go from right to left? Right to left or left to right? So as I told you, you're always going to be favoring the null position for the functional group of the parent. So we're going to be using this direction, which is going to be 1, 2, 3, 4, 5. So there's a 5 dimethyl alkene. If it was a triple bond, it's going to be alkyne. And if the constitution was another subconstitution, which is a methyl group, it's going to be a trimethyl, tetramethyl, and goes on like that. And now let's look at this one. It's a triple bond. So do we go from this direction or this direction? Let's count it. 1, 2. At 2 there is a triple bond. 1, 2. There is a 2 double bond. So it doesn't matter which way you're going to be using, because it's the same position. So 1, 2. It's going to be 2. After 2 there is a methyl group, which is going to be 2 methyl alkyne. But this can't be a complete naming for those two. There is something that misses here. So as for the double bond and the triple bond, what makes them different from that of an alkene naming? It is that we need to classify where the double bond or a triple bond posited. So we're going to be saying the correct structure is going to be 5,5 dimethyl. There's a double bond at the 2 carbon, so it's going to be 2 and then an alkene. Not an alkene, but instead we're going to say the total number of carbons. So it's going to be 1, 2, 3, 4, 5. So what is 5? It's pentene. So instead of alkene, we're going to be saying pentene. This is the correct structure. And for this one, you're going to be needing, say, 2-methyl. And then let's correct it by using where the position is a triple bond. So it's going to be 1, 2, 1, 2, 3. So in the 1, 2, 1, 2. So it is at the 2. So it's going to be saying 2, where the triple bond is found, and then we say 1, 2, 3, 4. There are 4 carbons, which makes them to be butene. Butene is for the double bond, so we're going to say butyne. That's a complete naming. And let's see the structure. As you see here, the carbon is surrounded with 4 carbons, which makes them to have 120 degrees. And it's a tetrahedral shape, and also, so we say that's in a common naming of an alkanes. If the carbon is surrounded by 4 carbons, we're going to say neo. So this structure is going to be neo. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be neo-octane. And now look at this structure and try it on your own for 1 minute. Okay, let's move on. If you see this structure at 1, 2, 3, 4, 5, 6, there are 6 carbons in total, and at 2 carbons there are 2 methyl groups, and 1, 2, 3 is going to be propyl group. So in this case, we're going to be using this direction. So in this direction is going to be 2-methyl, 2, 2, dimethyl, and then 4-ethyl hexane. But then this is not the complete structure naming. We're going to use the alphabetic order. So it's going to be E comes before N, so it is 4-ethyl, 2, 2, dimethyl hexane. Done. Let's move on and see those compounds. And look at this one. So it have a benzene structure here at 1 carbon, 2, 3, 4, 5, 6. It's hexane. And this cyclic one, there is a chlorine. So we're going to be counting like this: 1, 2, 3, 4, 5, 6. So we're going to be saying 2 chlorocyclohexyl, and then we're going to be continuing this one, which is going to be hexane. So it's going to be 2 chlorocyclohexyl. We're not going to be counting this one because this one is for the benzene. So this is going to be incorrect. It's going to be 1, 2, 3, 4, 5. So it's going to be 2 chlorocyclohexyl pentane. But if you see the structure, the benzene is attached to this chain, so which makes this structure to be incorrect, which is going to lead us to 2 chlorohexyl cyclopentane. This is the correct structure. Or you can add then the position of the cyclohexane, which is 1 or 2 chloro hexyl cyclopentane. This is also correct, but this one is more acceptable. And let's move on to the structure. So if you see there's 1, 2, 3, 4, 5, 6. At 3 and 4 there is a benzene, so it's going to be 3, 4 dicyclohexane, dicyclohexyl, because it's a substitution. When it's substitution, the hexene is going to be hexyl. That's why we said methane to be methyl. We say that methyl group, like chloro, this one's chloro substitution. When the substitution is made, there's going to be YLE, which is a methyl group, or it's homologous here, you know, and it's going to be dicyclohexyl hexane. Is going to be the correct structure. And now look at this structure. This is a benzene with chlorine and a bromine. Take a look at it and do it on your own for 1 minute. So let's move on and solve it. So from bromo and chloro, so B comes before C. So we're going to be counting from this one. 1, 2, 3, 4, 5, 6. Or this direction, which is going to be 1, 2, 3. So we're going to be favoring this one. So it's going to be 1 bromo, 1 bromo, and then 1, 2, 3. Three chloro, cyclohexane. I couldn't find any place, so just like, let's move it. So let's move on to the structure. So this might be your homework, and just solve it and comment it. If you have any questions, you can ask me directly. So in our today's lesson, if you paid attention, we talked about the nomenclature of a common names of an aromatic and the IUPAC naming of them. We solved many questions, and we saw those N, iso, and neo, and we solved those questions. And as your homework, do this and comment your answer, and we're going to be checking it. If you have any questions, just comment it. I'm going to reply. Bye.